So I've been having some questions about mass spectrometry and some of the basics about how it works and how it deflects ions to different degrees. So I just wanted to cover real briefly and really oversimplified the basics of how this instrument could work. And you start with a chamber where you would inject your sample, and usually the chamber is just so hot that the sample can break up. And you could make that so hot that you would atomize your sample if that's what you were interested in, but you don't have to. But the point is that the sample that you inject inside this chamber here basically gets broken up and ionized. And you can ionize it in all sorts of different ways, but let's just imagine, for the sake of simplicity, that inside this chamber here, we've got our sample broken up and ionized. Now, in our case, in class, we talked about using this technique to distinguish and measure the relative abundance of different isotopes of an atom. So let's just do that again. So if you can imagine inside this sample, we've got or inside this chamber, we've got our sample in all sorts of atoms all over the place, and some of those, and I'll try to exaggerate this a little bit, some of those will be a bit bigger because they'll be the heavier isotopes, and some of them will be sort of intermediate, and obviously this depends on which element type we have, all the available isotopes, but let's just assume we've got bits and pieces here, atoms that are of various sizes, because that's going to be important to understand how this instrument works. So these atoms are all inside this chamber, and we've got an evacuated chamber that you can imagine it following sort of a curve. So the idea is that our particles would, we would open up a little hole here in this chamber, and our particles would be flying out along this curve. Now, they're not necessarily going to take a curved path like that until we impart some sort of force. This is usually done with magnets, and you can do it in other ways, but let's just assume that there is a large force pushing our particles, in this case at least, downward. So the particles will now be coming out of this chamber and will be pushed downward by that force. So that's really the very overly simplistic basics that you need to know. So if we are talking about one of these large particles, for example, large particles coming out of this system, this force that I'm representing here is going to push on that particle, but the particle is so massive that the force doesn't really have a huge effect, and that particle is going to change its course by a little bit, but because the particle is so massive, the force really doesn't affect its trajectory too much, at least not relative to other particles. So let's imagine that heavier particle would have crashed maybe somewhere over here. If we instead imagine a lighter particle, and we can in fact just imagine the smallest type there, now as that particle flies through this chamber, that force is able to really affect that particle much more because the particle has so much less mass. So it's easy to push something small than it is to push something big. So this small particle will actually probably just get pushed very aggressively by that force and end up crashing somewhere in a much different place than where the heavier particle crashed. So essentially, heavier particles crash in a different place than the lighter ones do. And really all you have to do in principle is count how many particles crashed here, count how many particles crashed over here, and if your instrument is calibrated, you could tell exactly how many light particles you had in your sample, and you can tell exactly how many heavy particles you had in your sample. And so that way you can measure the relative abundance of heavy and light isotopes in your sample, and also specifically based on where they land on this trajectory line here, you can tell exactly how massive they are relative to the charge that they had. So that's the basics of how this instrument works. Very overly simplistic, but enough for our purposes in this class. So thanks for the question.